Hi again. This week we are going to keep thinking about indicators. And if you think back to our science lesson last week, we learned about an indicator called litmus. And we learned that litmus changes colour depending on whether you put it into an acid or an alkali. Now we will revise the colour change at the end of the lesson, but if you already remember that, well, that's extra good. Now this lesson we're going to make our own indicator, and we're going to make our own indicator using red cabbage. Now some vegetables like red cabbage that are strongly coloured contain dye, and if we can manage to extract the dye from the vegetable, well, we can use the dye as an indicator. And red cabbage is not the only vegetable like that. Other strongly coloured vegetables like beetroot could also be used as an indicator. Now, like I said, we're going to extract the dye and we're going to use the dye as an indicator. Now, we would do that ourselves if we were in school, but the next best thing, like I've said before, is that Mrs. Cummings does the experiment and we watch her, and we'll do that in a few moments. Now, what I'd like you to do is take a new page in your books, take the date and title the way we would do in school and underline them nice and neatly, and I want you to write in these notes just about red cabbage and to remind ourselves what an indicator is. And remember, you can pause the video as you need to. Now, if we think about how we would make this indicator, so we'll take our red cabbage, we'll chop up some of the red cabbage, and then we will grind it up in a pestle and mortar. And we haven't used one of those yet in school, but I'm going to show you a diagram in a moment. We would grind it up using a pestle and mortar. We would add 10 cubic centimetres of meths, which is just an alcohol. When we grind it up, we're releasing all the purple dye. Then when we add in our meths, well, the purple dye dissolves in the meths and turns it purple. So we've got lots of purple liquid. Then we would use a pipette and we would suck up all the purple liquid and we would put it into a little beaker. Then we can use the indicator to test all the substances we tested last week to see what colour this red cabbage indicator turns if it's in an acid or an alkali. And I've given you a wee hint there that not all indicators will change to the same colour. So all indicators have got their own colour change. Now we're going to make a few more notes. So on the same page, take another little title. And I'd like you to copy in the little diagram that I've drawn. So the first thing, like I've said, is we'll grind the cabbage up using a pestle and mortar, and I've drawn a little diagram to show you there. We'll add 10 millilitres or cubic centimetres of a liquid like methanol or ethanol. Those are just alcohols. Then we use a pipette to suck up the coloured liquid, which we will use as an indicator. Now the next thing that we're going to do is we're going to copy in a results table. Now remember, you can pause the video as you need to. Now you'll probably go on to the next page then, and this will be our results table. Now you can see that we have got 3 columns and we're going to test these 5 substances. So I'm going to play Mrs. Cummings' video just now. I'd like you to watch really carefully, and I'd like you to write in the colour that each substance turns with the red cabbage indicator. Now for now, ignore the last 2 columns. We'll come back to that after we've watched Mrs. Cummings' video. But you're watching carefully, and like I've said, copy your results table in first, and then you're going to write in the colour that each substance turns with this red cabbage.
Year 8. Ask Natalie how to make it your own indicator. In this mortar I have some red cabbage, and to it I'm going to add 50 ml of methylated spirits. And with a pestle I'm going to crush the cabbage so I can get all the red dye out of the cabbage. and as they say in Blue Peter, I have did some earlier. So I have 6 test tubes with lemon, ammonia, sodium hydroxide, hydrochloric acid, vinegar and lime water. And to each of these substances I'm going to add a red cabbage indicator. So into the lemon, it has turned it a pinky red colour. With ammonia, the indicator has turned the ammonia a greeny blue. Into sodium hydroxide, we have a dark green. Into hydrochloric acid, it's turned the acid red. And vinegar, the homemade indicator, has turned the vinegar a pinky red. And finally our lime water, our homemade indicator, has turned a greeny blue colour.
Now again, if we just check that you got those results written in correctly. So with the lemon juice, you could see that Mrs. Cummings called out that it turned a pink red. With the ammonia, it turned a green blue, but mostly green, I think. The sodium hydroxide turned a green colour. The hydrochloric acid turned a red pink colour, as did the vinegar. And the lime water at the end turned a green colour. Now, we've already considered these substances last week, and you might need to flick back in your notebooks to look at the colour. Now, we said last week that lemon juice, when we tested it with the litmus paper, was an acid, if you can remember that. We said last week when we tested this ammonia with the litmus paper that it was an alkali. We said that the sodium hydroxide also last week was an alkali. We said the hydrochloric acid, and the clues in the name, was an acid. And we said that vinegar was a weak acid, that it was safe to shake in your chips, whereas hydrochloric acid would be very dangerous if we shook that on our chips. Lime water is an alkali. Now, if we think back to litmus that we covered last week, we're asked what colour would the substance be with litmus? Well, if lemon is an acid, it would be red. If ammonia is an acid, if you think back, well, we said that litmus always turns blue in an alkali. And I might have said ammonia there was an acid, but I meant to say alkali, apologies. Sodium hydroxide would be blue with litmus. Hydrochloric acid would be red, as would vinegar. And lime water at the end, because it's an alkali, would be blue with litmus paper. So we've revised this litmus, but now we're looking at the red cabbage. We know that lemon is an acid, so therefore I can say that red cabbage always turns red pink in acid. And I think I'll try to keep it colour coded. So the colour of red cabbage in acid is red pink. The colour of red cabbage then in alkali, well, let's look at some of those alkalis. They would have turned blue with litmus, but look at ammonia, it's an alkali. Look at sodium hydroxide, it's an alkali. They will turn green with red cabbage. Now, folks, I'd like you to take another little title below your results table and write in the 2 sentences for the conclusion. Now, we've covered 2 indicators. We know about litmus indicator, and we need to remember its colour change. Red with acid, blue with alkali. We've made a homemade indicator now this week. Red cabbage is another indicator. It turns red pink with acid, and like we've just saw, it turns green with alkali. Now next week I will be asking you to do some practical work at home, and if you could get some red cabbage in time for next week, well, that would be brilliant.